Hello, this is Bill. Today we're going to continue with the CompT IT Fundamentals certification. We're covering Chapter 4 of our book. Chapter 4 is on data storage. As a quick refresher, remember a computer has four common hardware devices. These four devices make up a computer system. Your central processing unit, or CPU, that's the brains of your computer system, kind of controls how everything interacts. It's responsible for the overall function of the system. Your input devices are like keyboards, mice, microphones. Output devices are monitors, printers, anything that takes data out of a system. And storage actually is in two parts. The first was RAM. We covered that in a past chapter. And the last part we're covering today is data storage or long-term storage. Remember the differences between the two. Primarily, RAM is short-term volatile storage. It's a scratch pad used by your computer system. It will store data temporarily. If the computer loses power, the data that's in that RAM is lost. Hard drive storage is long-term storage. It's not volatile. It can function. It'll exist even without power. So we'll spend the next several minutes discussing this long-term storage. One thing I want to cover before we discuss storage is units of measure. Now, this looks very similar to what we've discussed in the past, where we had kilo, mega, giga, tera, and peta. What you're looking at here are the amount of storage. When we talk storage, we're talking bytes of data, not bits. In transmission of data, when we talk bandwidth, for example, we look at bits of data. So, kilobits per second, megabits per second, gigabits per second. In storage, we're looking at bytes. A kilobyte is 1,024 bytes of data. It's about 1,000 bytes. So a lot of times we'll round just to make it easy. A megabyte is about 1,000 kilobytes. A gigabyte is 1,024 megabytes, or about 1 billion bytes. Terabyte and petabyte. So again, what you remember in terms of storage, we're talking bytes. Now, you're going to see these same KB, MB, GB in transmission, and they're going to be in bits. The way we differentiate between the two is the capital or the lowercase b. Here, when we're talking bytes, it's a capital B. When we're talking bits, it'll be lowercase b. So just keep that in mind. If you see the capital B, it's bytes. Lowercase b is bits. A bit is a 1 or a 0. In terms of storage, a bit by itself really doesn't mean all that much. So what's a byte? Again, remember, we're talking about storing bytes of data. So a byte is 8 bits. And 8 bits is 1 character. For example, a capital letter A versus the lowercase, but a capital letter A is designated as 01000001. So it's 8 bits in that sequence is a capital letter A. I get that capital letter A in that sequence using the American Standard Code for Information Interchange, or ASCII. We'll discuss more about ASCII and what's called Unicode in a subsequent chapter. But here is a sample ASCII chart, just to give you an idea how some of this stuff works out. So again, the capital letter A, it's in the second column over here. Capital letter A right here, and here is our binary value of it. The lowercase a has a binary value of this. Don't worry about the ASCII codes here and here. We'll discuss those again in a future chapter. This chart and an extended version of this can be found here, or if you just go to Google or your favorite search engine and type in ASCII, ASCII chart, you'll see a lot of different options out there. Now, ASCII is a standard used to represent the English character set. When we talk storage, we're talking long-term storage. in this chapter, so just keep that in mind. It's non-volatile, so it survives a reboot and doesn't need power. You can take a hard disk out of a computer, put it from one computer to another, and the hard disk will still function. They come in three types. Magnetic, this is your classic hard disk, your spinning disks. Optical, which is CD, DVD, and Blu-ray. And solid state, which are your thumb drives, SD cards, or solid state drives, or SSD drives. Most of the large capacity storage is found internal to a computer, so if you find something 4 or 5 terabytes in size, that'll probably be inside a computer, not something you're going to carry around in a thumb drive. Storage can be external to a computer, again, thumb drives, some external SD drives, network storage, and cloud storage. So think of things like Google Drive for the external cloud storage. Magnetic storage, when we talk about storage, we're talking ones and zeros. So in a magnetic disk, it's going to be magnetic polarity or no polarity. So a 1 or a 0 is there magnetic polarity on that point in the disk, or is it missing that magnetic polarity? In an optical drive, a DVD, there's a laser that will shine down on a DVD or a CD or a Blu-ray, and it reads pits and lands. And basically, it's how the laser reflects off that CD or that disc. And if there's a pit or a land, one's a 1, one of those is a 0. The SSD drives use flash memory, which is a voltage by nature. It's non-volatile in the way it's stored. So, but you'll still have a voltage of some sort showing a 1 or a 0 in an SSD system or a solid state system. Magnetic hard drives or hard disks consist of a series of metal platters that are sealed in a box. These hard drives, these metal platters, are circular, and they have concentric circles that are called tracks on these platters. A hard disk can have anywhere from 1 to 5 platters and 1 disk housing. Along with the platters, there's an arm called armature that has some read-write heads that will move across each individual track on the hard drive. So this armature moves in and out, positioning the read-write heads over the appropriate track to read the data. These disks spin at very high speeds, from 5,200 revolutions per minute all the way up to 15,000. The faster the hard drive is spinning, as a general rule, the faster the disk is. Those read-write heads, when they're in an armature and they're moving back and forth, they're not actually touching the disk. They're actually floating on a cushion of air that is created when that disk is spinning. So those hard drive, the read-write heads never come in contact with that metal platter. If that were to happen, that is called a hard drive crash, and it actually ruins the disk. Modern drives, they do, along with the platters, they have a small amount of memory on them, or cache memory, and your typical cache sizes range from 16 megabytes up to 128 megabytes. Modern drive sizes range from about 500 gigabytes to somewhere over 10 terabytes, and they're constantly growing in size. Optical disk drives, we have 3 types of optical drives. Compact discs, or CDs, these are obsolete. You can still find them, but again, you're not going to buy them new as a general rule. DVDs and Blu-ray. Optical storage can be either read-only or read-write. Read-only disks can only be read by the computer, but the data can't be changed. Read-write disks can be read by a computer, and the data can be changed or deleted. Read-only disks are denoted with an R after the format of the disk. So DVD-R or BD is for Blu-ray. BD-R would be a read-only disk. Read-write disks are shown with an RW or an R/W for both CDs and DVDs, where the Blu-rays have an RE, indicating that it's a read-write disc. Disk capacities of our optical storage are here on this slide. So we have compact discs for 700 megabytes, DVDs 4.7 gigabytes, and there are 3 types of Blu-ray: single layer at 25 gigabytes, double layer at 50 gigabytes, and your triple layer at 100 gigabytes. Solid state storage is non-volatile flash memory. There are no moving parts. For this exam, it is more expensive than disk-based storage. It's lighter, faster, and more efficient than other storage options. Solid-state media types come in 3 basic types. Your USB flash drives. These, again, are external. They plug into a USB port on a computer system, and they provide additional storage that way. Flash memory modules. These you're going to find in cameras, smartphones, GPS devices, other type of devices that need these little small flash memory modules. And hard drive cases, also called solid-state drives. They're about the same size as a hard drive, and they look like a hard drive, but they're solid-state. These solid-state drives are replacing or augmenting disk drives in laptops, desktops, and servers. So it's not unusual to see, especially in servers, both solid-state and magnetic hard drives within a system. When we talk storage, there are a few types of storage we're going to talk about. The first is local storage, the network and cloud storage. Local storage is physically attached to the PC, server, or laptop. It's always available, so you don't have to have a network. If the machine's on and is working fine, the local storage is there. It's fast, it's convenient, it's not available to others. So as a general rule, you have that laptop, the data on that laptop is going to be there for the person that's physically attached using the laptop. You will hear the term direct attached storage, or DAS or DAS. Sometimes, and I'll use it later in this slideshow, you'll hear DAS-D, so it's direct attached storage device, DASD. Network storage is connected to a network, so the storage can be shared with others on the network. So you have a server in a server room or a wiring closet, and it's got a bunch of disk space on it, and everyone that's attached to that network, that where that storage is located, can access that disk drive or disk drives. The data resides on the server, and the server is configured to share some or all of its disk space. Cloud storage is available via the internet. Think Google Drive. Again, local storage can be called DAS, or direct attached storage, or DAS-D, direct attached storage device. Most of the times you're going to find some of it inside a computer system. So it's actually stored internal to the system. It's very difficult to remove, and it's very it's as portable as the device is. Laptop's very portable. Desktop's not very portable. A server is designed not to be portable. It gets its power from the PC power supply. It makes it more difficult to steal. Again, you may have to take the whole desktop or whole server with you. It doesn't take up disk space. It's internal to the system. On your internal modern disks, they connect to the system bus using a serial ATA drive cables and specification. That's a 7-wire data cable. The drives connect to the power supply using a 5-wire cable. In the older obsolete disks, they were using parallel ATA, which is an 80-wire ribbon cable that connected to the system with a 4-wire Molex connector for power. External storage, this connects to the PC using USB, Thunderbolt, Firewire, or external SATA, eSATA. Network storage is a storage that's accessed over a local area network, or a LAN, or a wide area network, WAN. There are 4 network storage options. One is a file server, network attached storage, shared volumes, and ad hoc networks. File servers, they are also referred to as just servers. They're dedicated full-time to serving disk space to other computers. These servers have fast, high-capacity drives, and they share those drives among multiple people. Network-attached storage is a special type of file server. It's a standalone device. It has 1 or more hard drives, or SSD drives. The network-attached storage, or the NAS, connects to the network. So again, 1 or more people can access it. The NAS device doesn't have a mouse, keyboard, or monitor. Sometimes you see these things called home media servers, but basically it's just a housing with 1 or more drives in it that sits somewhere on the network that people can get to. It's, again, no mouse, keyboard, or monitor, so you usually have to modify that using a web browser or something. Shared network volumes can be done on both servers or, in this case, individual PCs. So for this exam, if you see shared network volumes, we're probably talking about a folder shared on a PC. So this is where you as an individual might decide you want to share a folder that's on your laptop. You can share that out to 1 or more individuals across the network to access that folder. The down part to a shared network volume is when that PC or laptop that shares that folder is powered off or not connected to the network. That share isn't available to the network, so people can't access those files. Ad hoc network. This is where devices connect to each other without using the formal network infrastructure. So routers, switches, and servers are not usually available in an ad hoc network. Examples of the ad hoc network are a direct link. You take 2 computers, you connect them with an Ethernet cable. That Ethernet cable is specially wired as what's called a crossover cable, and they can share 1 or more. Both laptops will share out folders on their local hard drives. You can have an ad hoc wireless network. More computers use their wireless adapters to create a dedicated wireless network among themselves. So it's not connected to a corporate network, not connected to the coffee shop network. It's just a network among themselves. And in some cases, you can use Bluetooth to connect 2 or more devices to create a network. Online storage is accessed via the internet. So again, we're going online, Google Drive, Amazon Drive, OneDrive. They're, again, all available via the internet. Cloud storage is a special type of online storage. It's known as hosted storage. These are run by internet companies that charge a monthly fee for that access. It's available where there's an internet connection. If you're using a Chromebook, you're going to have to use cloud storage for most of your data. Cloud storage companies are Microsoft 365 or OneDrive, Google Drive, or Dropbox. The file transfer protocol is one of the ways we can transfer data among file shares or computers. So it's one of the oldest ways. It was actually developed when the early days of the Internet, or ARPANET, was created. The FTP is a protocol that contains rules on how to transfer and manage files. FTP is also an application that's used to transfer and manage those files. A real popular FTP application right now is FileZilla. FTP is not considered secure, so anyone that is watching that transfer of data can see usernames, passwords, and actually read the data as it's being transferred. If you want to use a secure alternative to FTP, there is Secure FTP or SFTP, and FTP over SSL, which is FTPS. Secure FTP or SFTP, it uses the technology for encryption very similar to what websites use when they use what's called TLS protocol, and you see a website that says HTTP or HTTPS. The S is the secure one. SFTP is secure FTP, uses the same protocol, the TLS protocol, in that transfer. FTP over SSL uses a secure socket layer protocol that's designed for encryption, and the FTP using the SSL secure socket layer protocol will be an encrypted link between two or more systems. Security in transit. So files are going from computer A to computer B across a network. So in some cases, we may not care if that data can be read in transit. You might be reading the latest version of Dale Brown's novel, and you really don't care if someone sees the contents of that file across the internet so they can read Dale Brown with you. Who cares? In some cases, you want that file to be encrypted. Mostly it's payroll data. You don't want people looking at payroll data. So you want to encrypt that as it's going from computer A to computer B. And there are different protocols to do that. So below is a quick chart I put together that shows some of the protocols that we've used when we're looking at systems on a network. The HTTP protocol is what our browsers use for web browsing. HTTP by itself is very weak in security. There's no encryption. If you're reading it, someone else can read it with you. HTTPS is stronger security. It is also used by a web browser, so Chrome can use both HTTP and HTTPS. The S is a secure mode of transmission, and that data is encrypted and cannot be read. Telnet and SSH both are used for remote console, basically taking control of another computer at a remote end. Telnet does not have any encryption. SSH has encryption. And then we have the three file transfer protocols, FTP, FTPS, and SFTP. FTP has no encryption capability. FTPS and SFTP both have encryption capabilities built into their protocols. Simple way of looking at this is to look for that S in HTTPS. In the FTP, either the S is the beginning or the end, and that S is a secure protocol. That's it for today. This is Chapter 4. I'll see you later with the follow-on chapters. Have a good night.